Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydroboration oxidation is a SYN addition reaction. Using B2D6, deuteroborane, instead of B2H6 means that deuterium, D, is delivered to the alkene along with boron in a concerted, SYN, CIS, fashion. The boron adds to the less substituted carbon, and deuterium adds to the more substituted carbon, anti-Markovnikov, both from the same phase. Moving on to the next step. 1-methylcyclopentene has the double bond between C1, bearing the methyl group, and C2. C1 is more substituted, C2 is less substituted. Moving on to the next step. In hydroboration, boron goes to the less hindered, less substituted carbon. Therefore, boron attaches to C2 and deuterium attaches to C1, the carbon bearing the methyl group. This is anti-Markovnikov addition of D. And for the final step, the addition is SYN, meaning B and D add to the same face of the double bond. Since the ring can be attacked from either face equally, but the key point is that B and D end up on the same face, CIS to each other on the ring. Treatment with alkaline H2O2 replaces the C2B bond with CO with retention of configuration at the carbon-bearing boron, C2. So O ends up where B was, on the same face as D. D is on C1 and O is on C2, both on the same face, SYN addition. This means D at C1 and O at C2 are CIS to each other on the cyclopentane ring. In option A, the product shows Me and D both on wedge, same face, at C1 and O on wedge at C2 with H on the opposite face at C2 indicating D and O are on the same face, CIS, which is consistent with SYN hydroboration oxidation. The methyl group and D are on C1, O is on C2, all consistent with D added to C1, more substituted, O replaced B at C2, less substituted, both on same face. Option B shows D at C1 and H at C2 with O at bottom. O and D are on opposite faces, trans, inconsistent with SYN addition. Option C shows O at C1 and D at C2. This would mean boron went to the more substituted carbon, C1, violating anti-Markovnikov regioselectivity. Option D shows O at C1 and D at C2 on opposite faces, both wrong regiochemistry and wrong stereochemistry. Therefore, the correct answer is A. Therefore, the correct answer is option A.